Hello everyone, I am Mr. Ashok Kumar from VTU projects.com and AKLC. So in this video I am going to briefly explain you about the project IEEE password authenticated key exchange protocols. We in short call it as PAKE, P-A-K-E, password authentication key exchange protocols. So all I'm going to do in this particular video is explaining you what actually this project does. I'm not going to bother about how we are implementing this, okay, because you are just started to learn this project. You are not a master of it, so you will be requiring a lot of time to understand the implementation part of the project, okay. So I request you people to go to your college coordinator and explain the project like the same way I'm going to explain you in this particular video, okay. So definitely they're going to ask you one or more questions like, you know, tell me more about the algorithm or tell me more about the technologies, etc, etc. So whatever questions they are going to ask you, so just promptly reply them saying that you just started to understand this project, you are not a master of it, so you will be requiring 1 or 2 days of time to answer those questions, okay. And all those questions your colleges are asking you, you people should be immediately redirecting it to me on this phone number, or you can type all those questions and, you know, mail it across to me on this email address. So I'm going to answer to those questions immediately, and then you people can go back to your colleges and answer to them, okay. So these are the things that I'm going to explain you in this video. So first I'm going to explain you something called quick facts. I mean some important points that you need to know about this project, and then I'm going to state the problem clearly, like what are we trying to solve in this particular project, and then I'm going to explain you the existing system along with their drawbacks, and then what system are we going to propose, and then its advantages, and at last I'm going to mention the hardware and software requirements for this project. Okay, so now coming to the quick facts. So these are some important points that you need to know about your project. So anybody like your project internals or externals or anybody who is concerned about your project might ask you these questions at any point of time. So answers to these questions should be ready at any point of time, okay. So those people might ask you what is the base reference, like where did you get the idea from, okay. So your answer for these questions should be, so this project is the idea of this project we got it from IEEE 2016 paper, the latest IEEE paper, okay. So that comes under, you know, security domain, okay. So I mean this project is an implementation of 2016 IEEE paper. So I believe you all got this, you know, base paper in an email from us, okay. So let me show you that IEEE paper. So this is the base paper for this project, okay. It's a IEEE paper that will be published in the year 2016, I mean the latest year, okay. So if you can see, there is some small information that has been provided towards the top of the IEEE paper. So if you can read out this information, it clearly says that this article has been accepted for publication in a future issue, okay. So I mean it is not yet published, it will be published in future, okay. So the reason why I'm letting this point know is because, so if you scroll down towards the bottom of that, you know, footer of this PDF, so if you by chance if you see this year 2015 IEEE, so don't mistake that this is a 2015 paper, no, okay. So 2015 is the year where authors got this article copyrighted, okay, but the year of publication of this IEEE paper will be 2016, so you need to refer here, okay. So it's a 2016 IEEE paper. So if you want to prove this to your colleges, then you have to go to IEEE you know, website, and you need to check, okay. So just copy the project title. So I'll just copy the project title, and then I'm going to, you know, IEEE official site. So just search IEEE Explore in Google, and the first link, okay, IEEE Explore Digital Library. So this is the official, you know, website of IEEE organization, okay. So here you just paste your project name, okay, and then click on search bar. So it is going to give you the result. So you can see this is the project that we are trying to implement, okay. So and there you can clearly see it's a IEEE transaction paper, okay. It's a IEEE transaction paper published in the year 2016. So 2015 was the year where authors got copyrighted for those articles. Okay, but in IEEE the year of publication will be 2016. Okay, so if you have the ID password provided by your colleges, so then you can log in and you can download the paper. But anyway, we already provided you the complete paper, right? So not required. So this paper will be published in the year 2016, not in the 2015. Okay, so that's about the base reference and the domain of this particular project. So and then coming to the algorithm. Okay, so the name of the algorithm that we are trying to implement in this particular project is ID2S PEG protocol. Okay, so it is the name of the algorithm that we are implementing in this project. So you don't have to explain the working of the algorithm right now, because you cannot understand its working. So you can only mention the name of the algorithm right now. The detailed working and the implementation part of that algorithm will be taught to you during the project classes. Okay, so just mention that you are going to implement ID2S PEG protocol. The expansion for PEG will be password authenticated key exchange. Okay, so and then coming to the number of lines of code, so we are going to write around 3000 to 4000 lines of code in this particular project. Okay, so you can compare these lines of code with any of the other institute project or any of your senior project and all. So they are going to finish the entire project within 1000 lines of code, or sometimes within 700 or 800 lines of code, like that. Okay, but this project alone will be taking around 3000 to 4000 lines of code. Okay, so not that we are simply complicating the project. The lines of code will be increased because we are implementing the complete IEEE paper. So some of the institutes and some of other students will be implementing part of the IEEE paper, and they will be leaving the some other part as future work. Okay, but we are not going to do like that. We are going to implement the entire IEEE paper. Along with that, we will also add some modifications, I mean some new features, new enhancements to the project. Okay, just to add weightage for your project. So what enhancement and what new feature will be added, all those things will be discussed in the day one of your project class. Okay, so and don't think that the project will be complicated because you have these many lines of code. So for each and every line of code that we are going to write, so you will be given a proper justification so that it will be easier to understand. So and then coming to the last point, the percentage of the database used. So we are going to use a maximum of 10 to 12% of the database. Okay, so the reason why I'm going to put across this point here is because VTU have a rule that we cannot use more than 20% of the database. We can use maximum of 20% of the database, but we are using only around 10 to 12% of the database, so we are in a safer side. Okay, so after developing the entire project, we are going to compare the number of lines of code we have written to the number of rows of data we have stored. We will be taking the ratio between them, and we are going to prove that we haven't used much amount of database. Okay, so if you are looking at these quick facts, so we are implementing a IEEE 2016 transactional paper. Okay, so and then the domain is security, and the new algorithm, the lines of code, and the percentage of the database. All those things will be adding a great weightage for your project and also for your resumes. So now coming to the problem statement. So here I am going to explain you what is the problem we are trying to solve in this particular project. Okay, so before coming to the problem statement, so I want you people to be aware of few prerequisites, I mean so few basic concepts that you people have to know. Okay, basic concepts like plain text, and what do you mean by ciphertext, and what do you mean by encryption, and what do you mean by decryption, and what do you mean by cryptographic system. So few basic terms you people have to understand. So I'm sure that you will be having knowledge about these things because you are going to learn it in your computer network subject. Okay, but anyway, I'm going to quickly give you an overview about these points. So coming to the first point, the plain text. So you people know that that plain data, the raw data before encryption, we call it as plain text. Okay, say for example Ashok Kumar. Okay, so this will be called as a plain text because it is a raw data, okay, without performing any encryption operation on that. Okay, and what do you mean by ciphertext? So ciphertext, So for this plain text, we are going to perform the encryption algorithm. I mean, we are going to apply some mathematical, computation, and we are going to jumble the words or do some lot of circus, and we are going to come up with an unreadable format. Okay, so this unreadable format, we call it as ciphertext. Okay, say for example something like this. Okay, so Ashok Kumar will be considered as the plain text because it is a raw data. Okay, whereas the 1 2 3 4 5 dollar hash, all these things will be considered as a ciphertext because it is an unreadable format. Okay, so this process of converting this plain text and ciphertext is called as encryption, right? So we are going to mention it using some formulas, like plain text will be called as P, so whereas ciphertext will be called as C, right? So encryption is the process of converting a plain text into ciphertext. So this plain text will be we are going to apply this encryption algorithm for the plain text so that we will be getting this ciphertext, right? So that process is called encryption. And what do you mean by decryption? That's straightforward. So the reverse process of encryption, we call it as decryption. Okay, so I mean we are going to apply the decryption function on the ciphertext. Okay, so to get back the original plain text like this. Okay, so we call this process as decryption. So from this unreadable format, converting back this unreadable format into the raw data, we call it as decryption, right? So, and coming to the last part, that is cryptographic system. So cryptographic system is anything that provides all the three operations. What are those three operations? Number one, key generation. Okay, I mean generating the private key and secret key and public key, like that. Okay, and number two, encryption operation. Okay, number three, decryption algorithm. Okay, so any system that provides these three functions, we call it as cryptographic system, like RSA. So RSA algorithms provides key generation technique, it also provides encryption technique, it also provides decryption technique. Okay, so RSA is one example for cryptographic system. Okay, likewise elliptic curve cryptography. Okay, elliptic curve cryptography is another cryptographic system. Okay, so I believe you people are aware about these basic prerequisites. Okay, just remember that why do we convert this raw data into unreadable format? So what is the need for converting this plain text into ciphertext? So to avoid someone from reading my plain text. Okay, so when actually this will be useful? So whenever we try to store the user passwords. Okay, so for example in my Gmail account I have a password called hello1234. So this password should not be saved as it is in the database, because anybody who accesses the Google database will be reading my password directly. Okay, therefore it should be encrypted and then it should be stored in the database. It should be stored in unreadable format. Okay, so this encryption is required anywhere and everywhere in the current world. So it's the most important operations that we need to focus on. Okay, so given that you people have understood these basic prerequisites of this particular project, so I will be coming to the problem statement. Okay, so the statement of this the problem statement for this particular project happens to be maintaining the privacy of user passwords. I'm going to write it here: maintaining the privacy of user passwords. Okay, so how will you maintain the privacy of user passwords? So this happens to be the most important problem that we have to solve right now. Okay, so I'm sure that I know that we are going to encrypt the user password and we are going to store it in our system. Okay, but how do you guarantee that that system will not be hacked by someone else? So if someone else hacks that system, and if someone else gets the access to my encrypted data, so he will perform he will somehow get to know how actually I encrypted, and he will perform the reverse encryption operation, and then he will be getting my plain text. Okay, so the problem statement which I am trying to explain to you people right now is how will you maintain the privacy of this encrypted password. We need to avoid those hackers from stealing this encrypted passwords also. Okay, so not just performing the encryption, so we need to also maintain the privacy of that encrypted data also. So how will you maintain that privacy of those encrypted data? So that's the problem that here the author discusses. Okay, so the author comes up with various existing system. He tries to understand the solution given by those authors, and then he mentions the drawback of those existing systems, and then he is going to propose a new system for maintaining the privacy of these encrypted passwords. Okay, so now coming to the existing system. So how currently the systems will be storing the passwords. So the entire password, I mean the encrypted password, will be stored in a single server. Okay, so in the existing system all this encrypted data will be stored in a single server. So this single server settings happens to be our existing system according to our IEEE paper. Okay, so I'll repeat, in the existing system the encrypted passwords will be stored in a single server. Okay, I mean the entire data will be stored in one single machine. Okay, so that's how the existing system works. Okay, so what is the drawback of storing the entire password in a single server? So in a single server setting, if the entire password necessary to authenticate the clients, if all those entire password are stored in a single server, then the drawback is, what if that server is compromised? So for example, hacking or even insider attack. Okay, the meaning of insider attack is let me take an example. So Google will be storing our password in their machine. Okay, they will be encrypting our password and it will be storing it in their machine. So if somebody else steals the password, we call it as hacking. Okay, if Google employees themselves, if they read the password, we call it as insider attack. Okay, so due to this insider attack or due to hacking or whatever other things are, okay, so this single server will be giving you lot of problems. Okay, so I'm just going to write down in formal words. So if the server is compromised, so due to hacking or insider attack, then the passwords stored in the server are all disclosed. Okay, so because the entire password is stored in one single machine, so if that machine is hacked, then all the users' password will be disclosed. Okay, so this is the drawback of the existing system. Okay, so I'm just going to quickly summarize. So the problem that we stated earlier is maintaining the privacy of user passwords. Okay, in the existing system, that user password are being stored in a single server. So the drawback of this existing system is, if that server is compromised because of hacking or insider attack, then the passwords stored in the server are all disclosed. Okay, so now coming to the proposed system. So to overcome the disadvantages of the existing system that we learned earlier, so we are going to propose, so we are going to design a compiler for identity based PEG protocol. Okay, so and we will be using for encryption and decryption, so we will be using identity based signature scheme. So let me explain you in detail now. So the expansion for PEG protocol is password authenticated key exchange protocol. So the name of the system that we are going to design will be ID2S PEG protocol. Okay, the expansion for ID2S is identity based. Okay, so in our proposed system, so we are not going to store the entire password in one machine. So instead we are going to break that password into multiple parts, and we are going to store that multiple parts into n number of different machines, okay, or different nodes, right? So rather than storing the entire password in one single machine, so we are going to break down that logic into multiple pieces, and we are going to store each partition of that password in a different machine. Okay, so the advantages of our proposed system is that, so even if one of the server has been hacked, entire password will not be lost. Only the part of the password has been lost. Okay, the hacker cannot do anything keeping that partition of the password. So you need to hack all the machines that we are going to use, so which is comparatively difficult than hacking single machine, right? So that's the advantage that we are going to get. Okay, so I can formally mention, the advantages of our system. Okay, number one, so even if a server is compromised, the user's password remains to be secured. Okay, and number two, so because the entire password encryption logic and the password storing logic has been done by multiple machines, we are actually distributing the load. Like performing the encryption, we are not doing in one machine, we are doing in n number of different machines, so we are actually distributing the load as well. Okay, so therefore I can say that we are achieving, as per the IEEE author, we will be achieving 22 to 66% of the computation speed. Okay, so I mean the computation speed, the rate of encryption speed will be increased by 22 to 66%. Okay, so I mean the time taken for performing the encryption will be reduced, right? And the third advantage of this particular project is that it can be readily used by anyone and everyone. Okay, so we will be developing this project in such a way that without any modifications, people in the current industry should be using it readily. So for example, if your colleges have an online portal where you will be logging in using your email ID and password, so they will be storing your password in one machine, right? So to improve their security, they can readily use this project and improve the security. So same way, even the banking people can use this, hospital industry can use this, any of the online websites like Facebook, Gmail, Snapdeal, Flipkart, any people who performs login operations can use our project readily without any extra modifications. They just have to plug in our access control code and paste it in their logic. That's it. Okay, so this will be the advantages of your system. So coming to the hardware requirements, so we don't need any specialized hardware to implement this project. So because this is a software intensive project, so we will be requiring a machine with 1.6 GHz processor, and we will be requiring a machine with 4 GB RAM and 40 GB hard disk. So this minimum configuration will be sufficient enough to implement this project. So coming to the software requirements, so here I am going to explain you in detail the software technologies we are going to use. Okay, so we are going to use some front-end technologies, and we are going to use some back-end technologies, and we are going to use some database, and we are going to use various other tools. Okay, so in the front end we are going to use Windows Builder. Okay, that is a library for Java swings and applets. Okay, I mean writing code in Java applets and swings is very difficult. Okay, so to make it easier, we will be using this Windows Builder library in the front end for designing the front end screen. Okay, and in the back end we are going to use core Java and advanced Java both. Okay, so and we are going to use MySQL database for our project. So just remember, we will be using a maximum of 10 to 12% of the database. So and we will be requiring some other tools like Eclipse IDE for developing our project. So Model Goon plugin for designing that class diagram, sequence diagram, etc, etc. Okay, so like this we will be requiring lot of other tools for implementing this project. So this is about the software requirements for this project. So that's it. So if you have any questions after watching this video, so please feel free to contact me on this phone number. So the best thing to do is you can type all those questions and email it across this email address, celestialcluster@gmail.com. So thank you so much.